So I do receive one announcement here is about the group work here. I do receive a couple of students wants to have a group like a doing homework together and maybe review for your finals or stuff like that online, not meeting face to face, doing Zoom. So if you guys are interested in doing this, you have to let me know so I can like set you guys up in a selected time and day. Probably I will do the Zoom since I got a Zoom account here from the school that can go for 2-3 hours long. Instead of you guys only, I think, have a 45 or an hour minute, 45 or an hour if you guys are doing on your own, if you don't have a Zoom account that you have to pay for. So we have, I mean, our school have that, so it's free for us. So so if you guys are willing to do, if you guys are wants to have this Zoom class, Zoom meetings with you guys doing your homework and stuff, and I might be Kami, I will stop by and check with you guys for like 10-15 minutes and see how you guys doing. So if you do like it, please send me an email and then I will set it up as soon as possible because the school is gonna end very soon, like in 2 weeks. So so that is one thing I want to point out is the group work. If you guys need to do some homework or meet together for doing your finals or review for your finals and stuff. And again, it's all Zoom. It's not going to meet in the coffee shop or whatever. It's going to be in Zoom. It's a social distance. So next thing I'm going to point out to you guys is again about the finals. Again, I don't know how many times I'm going to talk to you guys. Your final is no longer going to meet face to face, so it's not going to be in campus. Your final is going to be a Zoom testing. It's going to be on Monday, December 14, which is like 2 weeks from now, somewhere around 2 weeks from now. It's from 1 to 2:30. This is a Zoom link. This is in D2L, so I recommend you guys to go ahead and go to D2L and get it. I will remind you guys again next week regarding with these finals. It will cover chapter 3, 4, 5, and 9.1. Today we'll talk about 5.1 and 5.2. So you got like a few more sections left. As usual, there are 30 minutes before your finals. We have a review, 12:30 to 1 o'clock, and then the time, and then after that you have a finals from 1 to 2:30. You have to have a computer, laptop with webcam and mic, internet connection, scientific calculators, papers, and writing tools. Once you finish doing your test, make sure you scan your papers using either your scanner or download any scanning app like Cam Scanner or some other apps, and then send it to me to my email address. If you have any questions with this, please let me know because this is something that really, really important. Your final is 35% of your total grade. So if you miss my finals, you probably will get an F in the class. I can tell you right away. So please, 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 if you guys cannot come to take these finals around this time, you have to send me an email as soon as you can because I do not want to see the last minute at 1 o'clock. I got like 10 emails in that I cannot come to the finals on that day. I will recommend you guys to take a day off. If you guys are working, I will recommend you guys to take a day off on that day or half a day or something else so you can do my test. And then after 2:30, you can do whatever you want. And if there is a conflict between out of class finals with my finals, you also let me know because your teacher should already tell you when their final is. So if their final and this final class are having a conflict time, so make sure you talk to me, email me. This is very, very important. As I told you, this is 35% and you're going to do it as soon as you can. Do not wait. You got 2 more weeks before you hit the final. So make sure you guys do that. All right, so this is the finals. Anyone have any questions so far with the finals? So now we're going to talk about 5.1 and 5.2, which is due today. So you're going to do what 5.1 is called an exponential, and then 5.2 is called a log. So exponential and log are like inverse each other. So like multiply, divide, or addition and subtraction, like square and square root. So they are like inverse to each other. So that's the reason why that if you learn exponents, you have to learn log. So let's talk about exponents first. Does anyone have any questions on your exponential on 5.1 homework? You can either ask me or you can type out in the chat room if you have any questions on this 5.1. I also want to point out to you guys that chapter 5 is this exponents and log is full with calculators. So make sure you guys know how to use your calculator correctly to do this homework, like number 3 and number 4. These are all you have to use calculators to do it. So make sure you guys understand how you how to find 0.6 to the power 1.8. The symbol that we use here is a caret symbol. So a lot of calculator has this caret symbol that is the exponents. And so make sure you guys know. And then they also have the E symbol, not capital E, it's small letter E. That is for the exponents, the natural exponents in this case. Okay, the E. Does anyone here? Do I record? Does I record this? Sorry. Yep, I'm recording. Sorry about that. I thought you record. So, so questions on this? Yes, I see Bohar is asking something here. 13, I did all the box, but last one, no. So question number 13. This one?
Oh no, the one it has a box. Maybe I forget the number.
I did all boxes, but the last one. Do you know which one is it? Bohar, I do not know what. Is that on 5.1 or 5.2?
I will check. Give me a minute.
Yeah, please check because this one.
Yeah, the last.
Okay, 16. Okay, so but the last one. Okay, so you guys know. So this is one of formulas you guys need to know for this chapter. This chapter 5 is what we call as interest. So there is one called the compound interest formula, and the compound interest formula is for the interest given in the formula of A equals to P 1 plus R over N times NT. And if you put this in your calculator, this NT has to be in parentheses. Okay, so we do that. This is what we call as compound N times. So if you are using if you are doing question 16, the first one, N is 1, 2, 4, 12, 365. These first 5 boxes, you have to use this formula, where A in this case is what we call as your final amount. P in this case is called your principal. That means your initial amount or the amount that you first put in there. And then R is called the rate. This rate, the question usually give you in percent, like in this case is 4.5%, but you have to change it into decimals. And then T in this case is time. Usually the time is in years. And N in this case is how many times it compounds. So in this case, 1 means 1 time, 2 means 2 times a year. This is how many times it compounds in a year. So the first 5 questions, the first 5 box, we use this. So I'm going to give you an example here. So I'm going to use do number when N is 4 in this case. Okay, so I'm going to do this case. The rest is almost the same. So this question wants us to find A. The principal in this case is $1,000. 1 plus your rate. Your rate is 4.5%, so you have to put 0.045. So you have to change all this into decimals by dividing by 100 or move 2 decimals place to your left. And N in this case is 4 to the power of NT. 4 times N is 4. Time in this case is 11. So the first thing you guys need to do here is you have to do the 4 times 11 first. In this case, it's 44. Okay. So if you have a calculator, you can type all this in your calculator at one shot. But for my computer calculators, I have to do the one inside the parentheses. We had to follow the orders of operation. So for my case, maybe I can try to put everything in one. Let me see. 1,000 parentheses 1 plus 0.0. See, it's not taking it. So so actually I had to do synthetic. I had to do the so I had to do the parentheses first. So 1 plus 0.04 divided by 4 to the power of 44, and then after that you multiply it by 1,000. So this will came out to be 1,635.97. So I want to point out to you guys that for money, because it's all about money here, you have to automatically round in 2 decimal place because that's to the nearest cents. So this is how we do for n is 4. So for n is 1, 2, 12, and 365, we just need to change this n to the corresponding the number given to us. But for the last one, this is where it compound continuous. So when they use the word continuous, you do not use this formula. You use the PERT. A equals to PERT. You use this formula. This is only for the continuous case. So so this is for the last box here. That's what Boha asked me. So in this case, 1P is again is 1,000. E is the E symbol that all your calculators should have. Rate is 0.045 times time. Time in this case is 11. And as usual, if you have a calculator, you have to put a parenthesis on this the RT here. So for my calculators, and then you just put all this into your calculator and you get yourself your answer here. So for this calculator, I will have to do the parenthesis first. So I will do this one first, 0.045 times 11 first. And then I need to take the E2 of it. So this is the E symbol. Okay. E to the power of parentheses 0.045 times 11. So this is 1,640, 1 point something, and then you have to multiply it by 1,000. So this is what happens when you have a calculator like mine, where you have to do the orders of operation first. So this is 1,640.50 in 2 decimal place. So this is how we do the last one. Boha, you okay with that one? Boha?
Yeah. Yeah.
Okay. So make sure you know the difference formula. So if there's n, it's given n, 1, 2, 3, 1, 2, 4, is using this formula. If it's continuous, you use that formula. When n is, sometimes when they use the word n, they won't, like here, this is very straightforward. N is 1, n is 2, so you can plug 1, 2, 3, 4 in here. But sometimes they use the word like annually. So if you have the word annually, and in this case is 1, it means that you only compound 1 time a year. And if you have the word semi-annually means is 2 times a year. So and in this case is 2. And if the word quarterly is used, then n in this case will be 4, because quarter means divide by 4. So so if they say they're compounded quarterly, means it compound every 3 months. So a year got 12 months. So that means it compound 4 times. And monthly is for 12. That means every month they will compound the interest. And then daily is 365. So sometimes when you guys do the homework, they don't give you the n 1, 2, 4, 12, 33, 65 like that. They use this word annually. They compound annually, quarterly, monthly, or daily. Then these are the n's you will use here. I just want to point out to you guys so you guys will know what is the difference here. Anyone have any questions for me in 5.1? You don't have any questions for me in 5.1? Beside number 16? Right, no questions. So the next thing I want to point out to you guys is how to graph an exponents. This is very important, okay? So exponents graph usually is like 2x, 3x, 4x, and so on, so on. So in order for you to graph this, because this is in your finals in 2 weeks, so if I want you to graph this y equals to 2x, what you need to do here is you do the this is called the exponents base 2. So what you do is you can substitute numbers here. So like you always use 0 first. So when you plug in 0, you will get 1 because 2 to the power of 0 is 1. So this is a very important point in an exponent, the 0, 1 coordinates. So no matter it's 2x, 3x, 4x, 5 to the x, 10 to the x, the graph always cross at the y-axis on 0, 1. That means the y-intercept is 0, 1. Then you pick another number. Let's say we pick 1. So 2 to the power 1 is 2. So you get 1 and 2 here. And then if you do 2, it'll become 4 because 2 squared is 4. And then if you do like a negative number, like negative 1, negative 1 is actually 1/2 because 2 to the power of negative 1 is 1/2. So when you get negative 1, it is actually 1/2. So this graph will look something like this. This is the 2x graph, y equals to 2x. You find out that this at the left-hand side here, this line will not cross on the x-axis. That means it does have a horizontal asymptote. And the horizontal asymptote in this case is given to us by this y equals to 0. So it never crossed this. Okay, so this is the 2x graph here. Then what we have in this case is if I want you to graph 3x, 3x means that your graph will become a bit more closer to the y-axis. So when you have a 3x, your graph will look something like this, and it still cross at the 0, 1, and it still go parallel to the y-axis, the x-axis. So this is actually 3x, where when you put 1, this is actually at 3. And when you put 2, this is actually at 9, okay, because 3 squared is 9. And then next we have is 4x. So when you do 4x, 4x is even getting closer to the y-axis because at 1, it will be at 4. So when you have a 4x, your graph will be getting closer, but it's still going to touch at the 0, 1, and it will get even closer to the y-axis compared to the orange 3x. So this is 4x. So what happens, I want to tell you here is if you have 2x, 3x, 4x, 5x, 10x, whatever x you have, the bigger the number, the base number is, the closer the graph towards the y-axis. Okay, and then we have a special one. It's called the ex. Okay, so this is called the natural the exponents, the common natural exponents. Yeah. So so what we have in this e, if you look at the e is 2.718. Ex in this case is the same thing as 2.718x. So what happened is that means that it should be between 2 and 3x. So because e is 2.7, so 2 and 3. So in this case, if you want to draw the ex graph should be somewhere in between. It's still going to cross at 0, 1. So if you want to draw the graph of ex should be in between your 2x and your 3x graph. So this is your ex in this case. You guys all right with me here? You guys have any questions with the exponents graph? And this type of graph is called exponentially growth. The reason why is because if you read the graph from left to right, it is always increasing. Okay. And then when the next one we're gonna do is what happens if your x become negative. Okay, so this is the same thing as 1/2 x. Okay, so if you have a negative, it's half, means that now this base is between 0 and 1. Okay, that means it's a fraction. When you have such case, then your graph will have a reflections on the y-axis. So instead of doing it is going exponentially growth or increase, this graph will have an exponentially decrease, and it is still cross at 0, 1. So you just flip it. So instead of 1, 2, this will become negative 1, 2. Instead of 2, 4, it becomes negative 2, 4. Instead of negative 1/2, this will become 1/2. So what happened is you just flip it. So this is 2 to the negative x or 1/2 x. What happens when you have 3 to the negative x, or in this case 1/3 to the power of x? Then you will have the same thing as the orange line, which is going to be closer to the y-axis. So you get something like this. Okay. So again, it's not. So it's closer to the y-axis. It will cross at 0, 1, and then it will not. Again, it will not cross on the the x-axis. So this is 3x in this case, 3 to negative x or 1/3 x. So same property as this. If as long as you get closer and closer to the y-axis, this number, the base number, is getting in this case smaller because it's 1/3 and then 1/4 and then 1/10 x. So this is getting even smaller and smaller, and then the graph will get closer and closer. Okay. You guys okay with this graph? Questions you have? Okay. The domain and range for all exponents graph, your domain is always all real numbers, means it goes from negative to positive infinity. The range in this case is from 0 to infinity. So that means the range starts from 0, including, not including, sorry, this should be parentheses. It's not be bracket, this should be parentheses. So 0 to infinity, because it cannot touch 0, and it goes all the way up to infinity. So this is the exponent graph without transformation. So now we will talk about your transformation. So if you remember in chapter 2, we talk about a few transformation like moving up, moving down, left, right, reflection, X, Y, and all the horizontally stretch and compress and vertically stretch and compress. So we have all those transformation that you learned in chapter 2, and we will apply to here. So I want to point out for you guys to get confused, this 2x, 3x that you see here, EX, or 1/2, 1/3 x, this is not a part of your transformation. I repeat, the 2x, 3x, 4x, EX, 1/2 x, 1/3 x is not a part of the transformation. The 2x, 3x, 4x that you see here is just telling us how close is your exponents graph towards the y-axis. Okay, so the real transformation in this case is you have a number outside or inside or something like that. So let me give you an example in this case. So if you have 2x plus 1, means this will go up 1. And if you have 1/2 x minus 2, this one means you go down 2. So make sure you know that this 2 that you see here, the 2x and 1/2 x, has nothing to do with your transformation. So what is this means is the 2x is the one that you see on the red line that you have. This is 2x. So when I say plus 1 means you just move all this graph 1. So your graph will look something like this. So this is 2x plus 1. And then 1/2 x minus 2. Again, the red line you see here is a 1/2 x. So minus 2 means you go down to -2. So your graph in this case will look something like this. So this is what happens to your to this kind of transformation. Again, 2x and 1/2 x is just telling us what kind of graph do you have. Is that exponentially growth? And this is what we call it as exponentially decay. Okay. When you go up and down, if you have this transformation that goes up and down, it will affect your range. Okay, so no matter what kind of transformation you are doing, up, down, left, right, whatever you have, your domain in this case is still always all real numbers, no matter what kind. So if I ask you what's the domain for the first one, all real numbers. What is the domain of the second one? All real numbers. If I give you all exponential, your domain is always all real numbers. But when you go up 1, then your range is no longer 0 to infinity. Your range in this case will be 1 to infinity, because when you go up 1, the 0 plus 1 become 1. When you go down 2, then your range in this case is -2 to infinity. So make sure you guys know that when you go up or down, it will change your range. Okay. The next thing we have in this case is going left and right. So in this case, it is going to be up. So when you have a -1 on top, this you move to the right by 1. Okay. And if you have, I will use another one, +1, then this is moved to the left 1. So make sure you know that the sign is switched around. Okay. And when you move right or left, it will not affect your range and domain. Okay. So I want to point out to you guys, if your graph is just moving left or right, you won't, that means your domain is still all real numbers. Your range is still 0 to infinity in this case. If you have just this kind of transformation without going up or down, okay, just move left or right, you have this kind. You guys have any questions for me so far? Make sure you understand all this. Very important. It is in your finals. So should give you some examples that you know why I'm wondering about that. And then the next is the reflections. So if you have a negative in front of your exponents, or negative of 1/4 x, this is a reflection on the x-axis. And yes, it will affect your range. Okay, because what happens if your graph is reflected on the x-axis, the graph will go downwards. So your range is no longer 0 to infinity. Your range in this case will be -infinity to 0. So kind of like switch these two around. So that's the reason why that when you do a reflection on the x-axis and you're going up and down, you will change your range. Your domain is still all real numbers. Okay. Next, for reflections on the y-axis, the negative is on the power. Then you will have yourself a reflections on the y-axis. Okay. Questions for me so far? Anyone? Questions? When you do reflections on the y-axis, there is no effect on your domain and range. Okay. Next is a compress, and so when you have a number in front of it, like 2 times 3 to the power of x, again, this 3x is telling us the graph is this blue graph. This 2 is the transformation. So 3x is not the transformation, 2 is the transformation. So 2 in this case, the transformation tells us that this is actually its vertical stretch. Okay, so if this number is greater than 1, it's a vertical stretch. If this number is between 0 and 1, then we have a vertical compress. Or sometimes we call it vertical shrink, depends on the question. Okay, so what happened is that when you do vertical stretch or vertical compress, your y value will be multiplied by the factor. So this by 2 or 1/2. Again, when you have vertical compress, this number should be between 0 and 1. Okay, so for example, is let's say you have this graph, the same thing like 2x here. So what happened when you have 2 of it? So all your y value will be multiplied by 2. So instead of 1, this will become 2 now. And then last time here, this is going to be 3. At 1, this is 3. How do I know 1 is 3? Is because when you plot 1 here, 3 to the power 1 is 3. But now this 3 will be multiplied to become 6. So your graph in this case will look something like this. But it won't affect your range and your domain. That means your asymptote is still the same at y equals to 0. So what happened is actually that all your y value will be double. This if you have a 2 in front. If you have a half in front, means all your y values is cut into half. So that means your graph will look something like this, where it's no longer at 1, it's going to be at 1/2. So this is what happens when you have vertical stretch or vertical compress. And then the last one that we have is horizontal stretch and horizontal compress, is where you will have the number on the power. So when you got 3 to the power of 2x, then this is going to be a horizontal, this is the horizontal compress. And then when you have y equals to 1/2 to the power of 1/3 x, then this will be a horizontal stretch. So this is so depends on your power, your factor here. So when you have 2, that means you have it's greater than 1, it's a compress. When you have 1/3 or between 0 and 1, then you have a horizontal stretch. So remember last time when you do a vertical, your y value will be multiplied. This time your x value will be divided by your factor a. So that means that now your x value instead of 1, when you have a 2, you have to divide this by 2. So that means your 1 will become 1/2. And if you have 3, then it becomes 3/2. So when you have this 2, you have to divide it by 2. When you have 1/3, then you are dividing by 1/3. But when you divide by 1/3, it's the same thing as multiply by 3. So when you have 1, it will become 3. When you have a 3, it will become 9. So make sure you guys know that these are all the transformation for your exponents graph. And you in the test, I will ask you all this. So I will show you an example what is going on in your test, so you know your final, so you know what it is. And then this is actually worth a lot of points in your test. So does anyone needs to take a picture of this before I continue? Because this is very important. I'm going to save this too. This is export. So example in this case is, I think your homework is a bit easy to do. Let me see. This is easy. Yep, this is too easy actually. The homework is a bit easy. Example in this case, I will ask or be giving you something like this. Okay, so you know what it looks like. Y equals to negative 3x plus 2 minus 5 minus, let's say, okay, let's do 5. So first thing first is you have to tell me what is your parent graph, parent function. Remember last time when we do parent function is x squared or square root or absolute value and so on. So this parent function in this case is going to be 3x. And you have to graph this parent function. So how do you graph this parent function is you plug in numbers. So when x is 0, 3 to the power of 0 is 1. So you got 0, 1. When x is 1, 3 to the power of 1 is 3. When x is 2, 3 to the power of 2 is 9. And then your graph will look something like this. So this is your 3x, your parent function. You guys with me here?
Why we didn't take the negative?
I'm sorry. Oh, the negative is a transformation.
Oh, okay.
These are the one that is not in the orange box. They are all transformation. So how many next is a transformation? How many transformation do we have in this case? We will have 3 of them. the negative, the +2, and the -5. And do you remember it has to be in the correct sequence? That means that which one has to perform first. So which one should we need to perform first? The negative, the 2, or the 5?
The negative.
Don't forget, we follow orders of operation. PEMDAS.
Exponents first.
Exponents first, which is what?
+2.
+2. Yeah, +2 come first. That's the first thing you do. And what is this +2 means? Up, down, left, right, reflections. What do you have?
Up.
No.
Oh, it's left because plus.
This is left too. Yes, don't forget, when you have an exponent, you go left, right. And don't forget, the sign always switch. If you have plus, you move left. If you have minus, you move right. What's the next one after you do the +2? What's the next one? Negative or the -5? Which one should we do next? PEMDAS, which one should we do? The negative. Because this has been multiplied. -5 has been subtract. So PEMDAS means addition, subtraction always last. So what is this negative means? Is reflections on the x-axis. So this negative is a reflection on the x-axis. And finally, the -5. And what is -5 means here? You move down 5. So now what you need to do here is you have to take these 3 coordinates points that you have, and you have to move left 2. So when you move left 2, this will become at -2. Oops, sorry. It will become at -2, 1. Because at 0, 1, you move left, become -2. This one, when you move 2 to your left, it become -1, 3. And then when you have 2, when you move left, this will become at 0. So that means that your y-intercept now is no longer at 0, 1, at 0, 9. This is only the first transformation. This is where you move your graph left 2. What's the next thing we need to do is do the reflection on the x-axis. So you guys remember what happens when you reflect things on the x-axis? If it's on the top, it will go where? It will go to the bottom. So what happens when you reflect on the x-axis? Your y value will be opposite. Opposite means positive become negative, negative become positive. So this is at 1. Now this will be at -1. This one is at 3. Now it will be at -3. And the last one is at 9. It becomes -9. So this graph is the reflection on the x-axis. And then the last thing we do is you move this graph down 5. So when you move down 5, this -1 will be at -6. This -3, when you move down 5, will be at -8. And -9, when you go down 5, you'll be -14. So don't forget, you need to draw me your asymptotes. Your asymptote usually is at 0. When you move down 5, your asymptote will be at 5. -5. So, so this is your graph. The blue one that you see here is your final graph. You guys with me here? So in the test, I will ask you for the parent function, in this case 3x. I will ask you for transformation, which is left, right, or left, up, down, all those things. And then next, I will ask you for the horizontal asymptote. And in this case, your horizontal asymptote is exactly the same as if you move up and down. Since you move down 5, -5. And make sure when I ask you for asymptotes, make sure you give me the y or x equals 2. So a lot of students give me -5 and they won't get full points here. And then the last thing you need to tell me is the domain and range. And I told you before, for all exponents, I don't care 3x, whatever transformation you do, your domain is always what? All real numbers. Your range is the one that you need to figure out. So this is the range. So the lowest you can have is -infinity. And the highest you can have is on your asymptotes, which is -5. So this gonna worth around, let's say, 7 points here in your test. So this question by itself will worth 7 points. So I would highly recommend you to practice this. You guys with me here? If you want, I can give you a few of them. Y equals to e to the negative parentheses x plus 3. Put a 2 in front here. You guys want to try this one? So y equals to 2e to the negative x plus 3. First, you have to tell me what is your parent function is. Anyone know what's the parent function here?
It's E, right?
Yep, e to the x. So this e and this x is your parent function. So I just cross it out. That's your parent function. And the rest of those is your transformation. So how many transformation do we have here?
3.
Yes, you have 3 transformations. So that's part B. So which transformation should we use first?
Exponent.
Exponents, yes. So which one? We got the negative and we got the 3. These are all in exponents, right? So which is the first one you have to use?
X plus 3.
Plus 3 or the negative? Again, PEMDAS. Should we do plus 3 is addition, right? Minus here is being multiplied. So which one should we do first? Addition, subtraction, or multiply?
Subtraction. Multiplication. The negative
Yeah,
one.
this negative first. And what is this negative stands for?
Reflection on the Y.
Reflection on the y, yes. So this is the first transformation you do. What's the next one coming up? 2 or the 3?
The 3.
The 3, because it's still in exponents. And this plus 3 means what?
Doesn't it go
Remember, same
right,
thing, right?
or left 3?
Left 3. Don't forget the power is always left or right. And then what is this 2 stands for, the last one? This has been multiplied. So multiply in this case is going to be a vertical stretch because it's 2. So it's a vertical stretch. Remember last time when you do your parabola, this is your a. You know, when you say ax squared plus bx, that a. So if your a is like 2, 3, 4, your parabola is getting narrower because it's been vertical stretch. That's the meaning of it. Okay. So first you have to draw me your parent function first. Ex. So again, when you have 0, you get 1. When you get 1, e to the power of 1 is e. And what is e is? E is 2.7 something. You can use your calculator and point it out. So that is your 1. When x is 2, e squared. So you just use your calculator again and you square your e. Take your e and then you square it. You will get, they will give you a bunch of decimals. Let's see, e squared is what first? E to the power of 2, e squared. 7 point something. So when you have 2, this will go to 7.4. So this graph is your EX, your parent graph. This is you have to draw this in the test. You have to draw the parent graph. You guys all right here so far? So what happens when you do your first transformation? Reflections on the y-axis. Anything on the left will go to the right. Anything on the right will go on the left. But what happens if this is right on the middle on the y-axis? It stays the same. So if your point is at right on the y-axis, you cannot move left and right because it's right in the middle. This one is on the right, so you'll move to the left. So instead of 1, you become -1. This still at E, 2.7. This used to be at 2, now it will be at -2, still at 7.4 on the Y. So this graph, the green graph that I draw here, is your reflection on the y-axis. This first transformation. And what you need to do next, once you reflect on the y-axis, you have to move left 3. So this is at -2. So when you move left 3, this is at -5. So this is still at the 7.4. Doesn't change. This one used to be at -1. So when you move left 3, you'll be at -4. So this one is still at E, or 2.7. This one used to be at 0. You will move left 3 to 3. So this graph that I draw, the blue graph, is when you move left 3. And again, this will not cross on your vertical on your horizontal asymptote, okay, at 0 here. And finally, we vertically stretch. When you vertically stretch, your y value will be multiplied by 2 because you have 2 here. So now your 7.4, if you take 7.4 and multiply this by 2, this becomes 14 point something. So this point will be way up here now because it's going to be at 14 point something. And then the other one is 2e. So you take 2 times e, 2 times e. This one, it used to be 2.7, it becomes 5.4. So 5.4 is somewhere here. And this one used to be at 1, so 1 times 2 is still 2. So this 3 chocolate brown color point here is your final graph. Do we move up, down? Do we move up, down? We did not move up, down. So what happens to your horizontal asymptote? Since we did not move up, down, we didn't do reflection on the X, your horizontal asymptote is still at 0. That means this graph will never cross that. And what is your domain and range here? For all exponents, I don't care, it's EX or 3X or 2X, your domain is always all real numbers. And since we didn't move up or down, or we didn't do reflection on the x-axis, like what we did on the previous one, then your range will be 0 to infinity, which is the same because it's smallest. If you look at the brown graph, 0, and then you go all the way up. You guys all right here? Questions you have? Again, these kind of questions worth like what, 8-9 points in your finals. So make sure you guys know how to do this. And there are 2. One is for exponents and one is for log. So make sure that the next section is log. We'll talk about that. Okay, you guys want to take pictures or something else, please do so. Because now we're going to go through the next section, which is 5.2, which is log in this case. You guys okay? All right, anyone have any questions on 5.2 for me? Homework questions on 5.2? Again, class, I announced about the finals early on, so I think you guys already know the finals is no longer face-to-face. It's going to be Zoom on Monday, December 14th at 1 o'clock. So if you can, well, it's 1.5 hours long. So if you cannot take the finals, please email me as soon as possible. This is very important. And the next announcement is having a group study. So some students need group study for like a Zoom, not face to face. So if you guys interested in having a Zoom group study for your homework, for your tasks, for all those things that you guys want to study in groups, just send me an email so I can set up a Zoom and the time and the day. Because there are 2 students right now are interested, so I'm waiting for people to come to join so that we can set up a Zoom meeting. You guys have set up a Zoom meeting and do a like homework together. Again, it's all optional here, and I might stop by like 10-15 minutes to check on you guys. So make sure you guys, if you're interested, send me an email. All right. So next thing we're going to talk about here is 5.2, which is log. Anyone have any questions with the log? Anyone have any questions with the log 5.2 section? Anyone? I just want to point out to you guys with your homework next week. Okay, this is very special. So next week on Tuesday, you will have 5.3 and 5.4 homework due. And then next week, Sunday, you will have 5.5 and 9.1. So next week, you got actually 4 homeworks. 2 of them is due on normal time, Tuesday. And then the other 2 is due on Sunday. The reason why I put all this due next week is because that Monday after that Sunday homework is your finals, the 14th. So that means next week, the 13th, Sunday, you have 2 sections due. So next week, you got quite a lot of homework here. So that's the last 4. So next Tuesday, you will have 5.3 and 5.4. And then next Sunday, which is the 13th, you will have the 5.5 and 9.1. 9.1 is actually very easy. Oh, sorry, I put in the wrong one. Sorry, Boha. Should not private. So 9.1 is very easy, but 5.5 is tough. It's because 5.5 is word problems. And if you see some of the word problems here, you will see it again in your 5.5. Anyone have any questions in 5.2 before I continue with the graph of it? Again, very important about your chapter 5.2 log here is your calculator. Again, very important calculator. So you have log and ln. This is the only 2 buttons that you guys have in your calculator. When you have this log means it's a base 10, like this one. So this is base 10, okay? If you want to do log 7, your calculator do not have a log 7. So your calculator only have log base 10. We call it as common log, okay? This is called common log base 10. We have log base 7, log base 5, log base 2, and so on and so on. But your calculator do not have that to calculate that. So in 5.3, you will learn how to calculate like a log different base, like 3 or 8 and so on. Okay, so if your base is 10, so it's called log. There's no need to put 10. This is called common log. And if your log is a base E, it's called ln, natural log. And that is where the base is E. So I want to point out to you here. We have the normal log. So if I have log 100, this is a base 10. And this is what we call as common log. Okay. If you want to have a base E, this is called ln. We call it natural log. So this is a 2 different type of log. And then the normal one is like log 5 and log 2. So those students who have a sloppy handwriting, be careful how you write this, because a lot of students, this 5 has to be in the lower log. So we call it as a subscript, means lower. And then the 5, this is what we call as the argument. And then we have a power. Okay, so make sure you guys, those who have sloppy handwriting, make sure you guys know what to write carefully, because this 5 is supposed to be in the lower, this 5 in the middle, a bit bigger, and then this is like exponents, a bit smaller. Okay, so make sure you guys know how to write this. We have some properties of log. The first property we have here is given us if your base and your argument is the same, you get 1. Okay, so log AA is 1. So if you have like ln E is 1. The reason why is because ln is log E, so this is log EE. So that's why you get 1. Okay. The next we have is log n. So power n. This is gonna be n. So that means that if you have log AA, it will cancel out. Same thing here, ln E to the power of n. The ln E will cancel, you will get n. So for example, like this, log 553, this 5 and 5 is the same, you can cancel out. So your answer in this case is 3. You guys all right here? This is very important. Log A, if your argument is 1, not 0, is 1, you will get 0. Okay, so log A1 is 0. ln1 is also 0. Okay, so if your argument here is 1, you get 0. Questions with me? This is very important. I'm showing you here. Log A0 and log A, any negative number is undefined. Same thing with ln. So ln 0 and ln with any negative number is undefined. You guys with me here? This is called log properties in 5.2, and you need to know this. This is very important. For example, is like here. Anyone know what log 55 is? Anyone know what log 55 is?
1.
1, yep, log 55 is 1. This is 1. Anyone know log 8.51?
0.
0, because anything with a 1, you get 0. Okay. This one is special. If you have a 5 and log 5, it's like what we did here. When you have a base and an argument the same, they can cancel out. So you get n here. So can someone tell me what's 5 log 5 2?
It's just 2.
Just 2. The 5 and the 5 will cancel. Log 5 will cancel. So this is just 2. You guys okay here? Now, this is called one-to-one property. One-to-one property says that if your log is exactly the same base, if you want to solve a log equation, then you just make your argument the same. So in this case, for example, is this 2, they have both log 2, right? So this log 2 can cancel out. So what you left in this case is x minus 2 equals to 3. And x in this case will be 5. So this is your answer in this case. So very easy questions here. So if you this is what we call as one-to-one property. So if you have a same base log, then you just make the argument equals and you solve for it. Like this question, you might need to factor it and try to solve it. You guys all right here with log here? I'll show you how to graph it, which is the important part. Anyone okay? Okay, so I'm going to show you how to do a log graph. So log 2x is the same thing as graphing 2 to the power of x. If you remember how you draw 2x, we got 0, 1. We got 1, 2. And we got 2, 4. Remember that? And then at -1, we got 1/2. So this is your graph of 2x. So now how you graph log 2x. Log 2x is exactly how you graph 2x, but now instead of this is your y-axis, it will become x-axis. So your x-axis in this case, this coordinates is 0, 1, right? And don't forget, because it's inverse, your coordinates will be switched. So 0, 1 will become 1, 0. This coordinates is 1, 2. And when you switch, it becomes 2, 1. This coordinates is 2, 4. And when you switch, it becomes 4, 2. And this coordinates is negative 1, 1/2. And when you switch, it becomes 1/2, negative 1. So this is your log 2x. And you notice that it never crosses on your y-axis. That means it has a vertical asymptote at x equals to 0. Last time over here, it has a horizontal asymptote at y equals to 0. So this one is been switched around. And as I reply, I recall back to you guys, what happens when you draw 3x? This graph is closer to your y-axis. Same thing happens, but happens when you draw log 3x. This graph will be closer to the x-axis. So you got the 1, 0 here. So instead of 2, this will become 3, 1. Now, how do you figure out all these numbers on the x-axis? Is you take the base and you power it. So this one is 3 to the power of 0. That's why you get 1. This one, you will get 3 to the power of 1, which is 3. This one will be 3 to the power of 2. Do you guys know what 3 to the power of 2 is? You get 9. And then the next one, if you want to do, will be 3 to the power of 3, which is 27. You will get 3. So this is your graph of 3x, log 3x. Okay, and then same thing happens to log 4 and log 5. And then remember last time when I called you to graph the EX? EX is between 2 and 3. So EX is somewhere around like this because E is 2.7 something. So what happens when I want you to graph lnx? Lnx is also the same thing as EX, which is also between 2 and 3. So this will look something like that. It's still going to cross at 1, 0 here. So this blue line is what we call as lnx. Okay. And then, so make sure you guys know about this. This is very important. So this is what we call as your parent function. Log 2x, log 3x, lnx, so on. So now we talk about transformation. Yeah, we have transformation. So when you have log x plus 1 or ln x minus 2, this means that you go up 1, and this means you go down 2. So make sure you guys know that without parentheses, it goes up and down. But what happens if you put a parenthesis on it? So be careful with parentheses here, it means something. So once you have a parenthesis, this will go left 1, and this will go right 2. So make sure you guys be careful with your log transformation. Okay, parenthesis is very important. Next is negative. If you have a negative in front, or negative in front of ln, this means this is reflections on the x-axis. And if you have a negative inside your log, then this is reflection on the y-axis. And then same thing with the vertical shift and vertical stretch and compress. If you have 2 log 2x or 1/2 lnx, this 2 is going to be a vertical stretch. This 1/2 will be a vertical compress or vertical shrink. Okay. And then when you have your number is inside, then you don't have a vertical, you have a horizontal. So it used to be a vertical stretch if you have a 2 outside. So you're totally opposite. Vertical is horizontal. stretch is compressed. And this 1/2, it used to be vertical compressed. Now it's going to be horizontal stretch. So usually I take this and kind of like do an opposite of it. So these are all the transformation that you have. So be careful with the parentheses and no parentheses. It means two different things. So be careful. I just want to tell you that. Anyone have any questions with me here? And then we'll do domain and range for this case. For this case, as you guys remember, the domain here is always all real numbers. Range in this case is from 0 to infinity without any transformation. And if you guys remember what happens if you have an inverse function, your domain and range is switched around. Remember the first test you do. So what happens to your domain for a log function? Instead, it will be 0 to infinity, and your range will be all real numbers. So you just take the 2x, 3. If you know the domain for 2x, 3x, ex, then the domain for log 2, log 3, and ln(x) will be switched around. So this is very important. So for my type of work I give in the test, it looks something like that. Negative log 3x minus 2. So you need to tell me what is your parent function here. Does anyone know it's a parent function for this case? This is the parent function. This is called a parent function.
It would be the log 3.
Yep. So parent function in this case is log 3. So if you cancel the log 3x, sorry, we have x inside, log 3x. Again, this 3 is a small 3. So if you cancel the log 3 and the x, the remaining is your transformation. So what transformation do we have in this case? The negative and the minus 2. So which one should we need to do first? The negative or the minus 2? PEMDAS. What's PEMDAS means? What's the P stands for PEMDAS?
Parentheses.
Parentheses. So we need to do the parentheses first.
So negative 2.
Which is negative 2. And what's minus 2 means here?
To the right 2, is it?
To the right 2, yep. And then what is the negative in front of this? Is this negative? Is a reflection on the x or reflection on the y?
It's on the x, right?
This is reflection on the x because the negative is outside. The reflection of x. So what you need to do is you draw the log 3 graph, which is the green graph that I have. So I'm going to redraw it again here. So you will have this graph. This is the log 3 graph, which is you will cross at 1, 0. And then this is 3, you will get 1. And then 9, you will get 2. Some of you are asking me, it's like, yep, like a square root. So if you take a square root of 3, you get a power. So this 3 to the power 1, this 3 to the power of 2, you get 2. So this is your log 3 graph. This is your parent graph. So what you need to do first is you have to move right 2. So this one, when you move right 2, will become 3. This 3, when you move right 2, become 5. 9, when you move right 2, will become 11. So this is your moving right 2 graph. So next, once you finish moving right 2, you have to reflect this on the x-axis. So this point, because it's on the x-axis, you do not need to reflect. This used to be 1, 5, 1. It becomes 5, negative 1. This one to be 11, 2. It will become 11, negative 2. So this is your final graph of this negative log 3x minus 2. But since we move left and right, it will affect your domain, or it will affect your horizontal asymptote. So your horizontal asymptote initially is at 0 because you move right 2. So your horizontal asymptote in this case will be 0 plus 2, which in this case 2. So this is very important. A lot of students did not draw this line, and if this blue line cross 2, I will mark you wrong because it should not cross 2. It should be parallel with 2 here, okay? Because that's your asymptote. So your horizontal asymptote in this case will be x equals to 2, not y, x. What's the domain and range for the blue line? Domain, because it never crossed at 2, so it will go from 2 to infinity. So the horizontal asymptote is actually determining your domain here. So since 2 is the one that you cannot cross, so you go from 2 to infinity. Your range in this case is all real numbers. So I want to point out to you guys, if you draw any log function or ln function, the range is always all real numbers. If you're doing exponents, your domain is always all real numbers. Okay. Only your domain, only for log function, domain is the one that you need to watch out, because that if you do a transformation doing left or right, it will affect your domain and your horizontal asymptote. You guys all right here with this? Again, this kind of questions that I just give it to you will be in your finals. So make sure you guys understand this. This is very important. Again, as I told you, in your finals, you get 2 types. One is an exponent type, and one is a log type, and they are worth like 7, 8 points, like what I just did over here. So you will have like 16 points already in your finals, just drawing the graph of exponents and log. All right, does anyone have any questions? You guys want to take pictures? Go ahead and take pictures, because this is quite important here. Before we end our class here. Anyone have any questions for me? Anyone? All right. So make sure you guys, if you have any questions, please email me. Again, I want to point out to you, you got quite a bit more homework due on next week. 2 homework due on Tuesday, 5354, and then 2 due on Sunday, 55 and 91. We only have 1 more Zoom class left, which is next Tuesday on 8th. And then the other Zoom class will be your finals, which is on Monday, the 14th. So actually we've got 2, 1 is for the class and 1 is for your finals. So we have another Zoom on the 8th, and then we have a finals on the 14th on Monday. Anyone have any questions for me before we stop here? Anyone?
No, thank you.
All right. If you, yeah, I will definitely post this Zoom later. Yeah, you'll be on there. If you have no questions, you may go. If you have questions,